Okay, so I'm going to use a different data set than the one I gave you for homework, but I'm going to show you how to do all the things I've asked you to do. So this is the body mass index data set that I gave you in the beginning of the semester, and we've got gender, which is nominal, race, which is nominal, height and weight are ratio, and index is ordinal. The first thing I'm going to have you do is run a histogram, and we'll do it, let's see, we'll do it on height, now let's do it on weight, let's do it on index, just to see. Go to charts, I'm going to do histograms. I'm not going to show the normal curve, I'm just going to show the histogram, and I don't want these frequency tables. Okay, so height looks slightly skewed to me. Actually, you know what, let's run it again. And let's see if it'll give us a skewness, and we don't really care about kurtosis. Let's go ahead. Alright, so we have all of these are slightly negatively skewed. So it's easier to actually have it calculated for us than to visually evaluate it, but it's good to look at both. Okay, so this one, height is just barely negatively skewed, and I think it's probably because of this one tall bar here. Weight is a little bit even less negatively skewed. It's more of a uniform distribution, but because of these slightly taller ones. And then this one, index, is definitely negatively skewed. You can see, there it is. Alright, so the other thing I'm going to have you do is do a QQ plot. Let's do QQ plot. Let's go ahead and, I've got it auto-populated. You can hold down height. You can click on height and hold down shift, hit index, and it'll grab all three. Let's bring it over and let's see what we get. Alright, so we have, if it were completely normal, these would line up on the line. We can see that they don't. And we have slightly negative skew. We know from our calculated kurtosis this is also not lining up. And then this last one, these also don't line up because we only have 5 values. That's why it looks different than the others. All right, now we're going to do a one sample t-test. And I'm going to go to Analyze, Compare Means, One Sample T-Test, and hit Reset. I'm going to do height. Oh, you know what, before I do that, let me do Analyze, Descriptives, Descriptives. I've already brought these guys over. I want everything that it's going to just automatically, I'm going to take max and min away. I just want the mean and standard deviation. You can leave it, it doesn't matter. I'm going to say OK. Alright, so our mean is 169.94 and our standard deviation is 16.4. And that's for height, and for weight we have 106 and 32. So I'm going to test against 170 for height, and then I'm going to test again for against 180. So I go to Compare Means, One Sample T-Test. I'm going to bring height over, and I'm going to say let's test against 170. It's practically 170 now if I round, so it's not going to be significant. So what do? We look, here's the same information that we just got up here. It's just giving it to us without us having, SPSS loves to give us output we didn't ask for. But it gives us this, because you do need it. We come down here and we see our t-value is negative 0.076, so pretty small. Degrees of freedom is 499 because we have 500 in our sample. Take away 1, that's 499. Our sig2 tail, this is our p-value. That's not less than 0.05. It's huge. It's 0.939, so it is not significant. We do not reject the null. It is not different than 170. Here's our test value. It is not different. This is the mean difference, and then here's our lower and upper limit. Because 0 is inside this lower and upper limit, negative to positive, it crosses 0, we know that it is not significant. Alright, let's test it again. I'm going to go to this recall dialog box and test it against 180. Alright, let's see what we get. Now we're testing against 180. We've got the same information, nothing different. And we've got negative 13 is our t-value. That's huge. If you think about the normal curve, remember within plus or minus 2 standard deviations, z-scores, we were not going to reject beyond plus or minus 1.96 actually for a two-tailed test. We would find significance. And here we have 13. So this is negative 13. So in a normal curve, we'd be way off the charts, right? And we can see with our p-value, we are highly significant, 0.00. And you never report your p-value as 0.000. You always put a 1 there because this is just giving us 3 decimal places, and it's never 0. It's always, you just put 0.001 or 0.1, either way. All right, and then we can see that both of our limits are on the negative side of 0, so we know that it's different than 0, so we know that it's significant. And then here's our mean difference. So let's calculate our Cohen's. I'm going to pull up my calculator. All right, so I'm going to use my mean difference divided by my standard deviation. So I don't care about the negative sign, so I'm going to say 10.1, because I'll round up with that 5, divided by 16.4, and I'm going to get 0.62. So that's a medium effect, right? A little bit more than 0.5. So it's a fairly medium-sized effect. Not bad. That's not bad at all. All right, let's do the other one. We're going to throw this guy back, and we're going to do weight. And remember, our weight was 106, so we'll do it against 105. And this one's not going to be significant, right? We look at our p-value, it's 0.49. That is not less than 0.05. Our t-value, all that's the same. These also, it crosses 0, right? So negative and positive, so the 0's in the middle here, so we know it's not different than 0. And so that's not significant. So we don't really even need to do a Cohen's, but I'm going to go ahead and do it anyway because I asked you to do it for significant and non-significant values. So that'd be 1 divided by 32, practically negligible, 0, very no effect, and that's because it's not significant. All right, let's do it again one more time, and let's do it against 115. And we say okay, and we've got highly significant, -6, mean difference of 9. Pull up our calculator. 9 divided by 32, and we get a small effect. All right, that's how you do it.